We are not allowed to have square roots on the bottom. We don't just have a square root, we have a square root expression, which means that instead of multiplying by a square root, we're going to multiply by another expression. Because we are going to have to multiply by an entire expression, the only way for us to cancel all the square roots on the bottom is to use what we just said a second ago is called the conjugate. The conjugate means instead of root 7 minus root 2, we will multiply by root 7 plus root 2. Same thing on the top and the bottom. Whatever you do to one side, you have to do to the other. So all I did was take the expression I had, root 7 minus root 2, and I just changed the sign in the middle. Instead of minus, it's plus. Here's why this works. If I multiply this out, the top is very easy. I'm distributing the 10 into here. Some people like to put parentheses around this to make it look more familiar. It's not necessary, but if it helps you remember what to do, then do it. I'm essentially then just distributing on the top. 10 times root 7 is 10 root 7. 10 times root 2 is 10 root 2. But on the bottom, this is what I'm working towards. I want to get rid of all the square roots, and here's what this lets me do. By using a conjugate, I am guaranteed that the terms in the middle, when I multiply everything together, the like terms will cancel each other. And I will end up with nothing but whole numbers. So let's do a little distributive property underneath here. If I do root 7 times root 7, I get the square root of 49. If I do root 7 times root 2, I get the square root of 14. If I do negative root 2 times root 7, I get the negative square root of 14. If I do negative root 2 times positive root 2, I get a negative square root of 4. You'll notice in the middle here, square root of 14, square root of 14, those are like terms. But you should also notice, and this is why we did this, it's 1 root 14 minus 1 root 14, which means they canceled each other, and they're gone. And you say, but I still have square roots, but look at those square roots. The square root of 49 is 7. The square root of 4 is 2. And if I put them together, I just have a whole number, 5. So I have a 5 for my new denominator. And we've accomplished what we wanted. There are no square roots left in the denominator. It's a longer process to understand how we got there, but we no longer have square roots. This problem is not complete. There is still something I can do. Does someone see what it is that I can do here? Look at what I have on the top compared to the number that's on the bottom. Christian?
Oh, so you could simplify it as a fraction?
I can. I'm going to reduce them like fractions. They both have 10 on the outside, and there's a 5 on the outside here. 10 over 5, 10 over 5. They reduce the exact same way, so what I actually end up getting is 5 goes into 10 twice to make 2 root 7. 5 goes into 10 twice to make 2 root 2. And that becomes my final answer. You will not always be able to reduce at the end. Sometimes this here, before we reduced it, will be your final answer. What if I had a 3 there instead of a 5? 3 doesn't go into 10. I would have left it exactly how it was. So sometimes you'll leave it, but if that denominator goes into both of those coefficients on the top, you need to do that.